This is Science News, and I'm Ellie Moss. Today, we're covering the Doppler effect. Let's head over to our reporter at Washington National Airport.
We're here at National Airport. Listen to the change in pitch as this plane goes by. Take a look at the ripples we make when I pull the stick through the water.
Oh, I get it. So the sound waves bunch up in front of the stick and they spread out behind it.
Now that's the Doppler effect. Back to the office.
That was so cool, but what does it all mean? Now over to the whiteboard with an explanation. Welcome to the whiteboard. Today we're going to take a closer look at the Doppler effect and see how the sound waves create different pitches. Imagine a stationary ambulance with its sirens on. When an ambulance isn't moving, its sound waves are all equal distance from each other. This means that no matter where you stand in relation to the ambulance, you will always hear the same pitch because the wavelength is always the same distance. So if that's what the sound waves look like when the ambulance is stationary, then what do they look like when it's moving? That's a good question. This time, let's imagine a moving ambulance and its sirens are still on. If you take a look at the sound waves, you'll notice that they are bunching up in front of the ambulance and they spread out behind it. As the ambulance approaches you, you will hear a higher pitch, and as the ambulance drives away, you will hear a lower pitch. This is because the less frequent or longer the wavelength is, the lower the pitch, and the more frequent and shorter the wavelength is, the higher the pitch. The Doppler effect works with color shift too. Let's test it out.
When the stars move away from the Earth, the color that we see changes from blue to red. This is due to the Doppler effect. It's called redshift. Let's see if we can replicate it. Did it work?
Wait, but the color didn't change. Read my paper to find out why.